And we're back. It's COMP305. It's Game Programming 1 in the winter 2016 semester. And it's week 2, lesson 2, part 2. And in lesson 2, part 2, I want to talk about a little bit about Unity scripting, right? So again, we talked about where to find the find manual, which we talked about before. So if I was going to bring up the find manual in Unity, notice how if I go to Unity 3D, so docs.unity3d.com, and if I click on manual, right, I get this address, docs.unity3d.com/manual/index.html. Right, that's the actual manual that we'll be using for this entire semester. Right, this is the best manual you can get because it's up to date. Now there are some books out there that can help you with the manual, right? Books that give you some patterns to create certain things, and we'll be talking about some patterns together in the course, right? To try and make you have to create your 3 games. Remember, in the course you'll be making 4 games, right? At the minimum, 4 games. The first one is the first assignment, second assignment, third assignment, then your final, which is you're going to be combining with 1 partner, maybe 2, depending if you make a good case for your final project, right? Your final project is heavily weighted, right? So keep that in mind, and it's going to be broken off into a few parts for us to manage together. Okay, so in my Unity manual, there's 2 different options I have up here. I have the manual and I have the scripting API. If I click on scripting API, it gives you a little bit different options here. And notice that you can have 2 different script options on the right-hand side, the C# option and the JavaScript option. We're not going to be using JavaScript in this course, right? So please don't, if you clicked on the JS option, it's not something that we're going to use. You can search here in the search bar. The fastest way to find something is to search something up here in the search bar. When you look at the scripting API, if I want to look at something like, for example, my start method. So if I say my start method, and if I kind of enter, it'll look through and it'll find whatever it can in the scripting API that's related to start. One day when my computer goes down. So you see there's a bunch of different things here that it'll find. Start, right? And there's also, if you look at the Unity engine, if I look through here, notice that there's a bunch of stuff in here for Unity scripting and attributes and so on. So instead of you swimming through this and trying to find all your own stuff, I've kind of put it together, some brief stuff that I've taken out of the manual into this PowerPoint presentation, right? That's why I kind of created this for you. And the few things that I want to talk about are, let's talk about event functions and how they work, because everything we do in Unity when we make games, pretty much, we need an event function of some kind, right? And the other one is, let's talk about our game object class. We already said it. Game objects, they all have the transform component, right? We have to talk about that. And how do we get input? Because how do we move an object around? Like I need to get input from somewhere, like the keyboard or the mouse, right? How do I get input and what's my input class? By the way, this applies to Unity 4.6 and Unity 5, or whatever 4.x and 5.x. All right, so when we talk about order of event functions, execution, whenever you kick off your game for the first time, when you start running your game, right? It starts off like this. All things that modify the editor, that's the first thing that starts running. Then the next thing is the first scene gets loaded. And then after that, we do this before the first frame update. And then we do this in between frames update. And we keep going through this until we get to coroutines, and coroutines are like a separate process altogether, right? So this is kind of the execution order that it follows. Now, it's a very high-level execution order, and for you guys to remember it, I don't expect you to remember it. I'll tell you when I need you to remember something. So here we go. So here's my editor. And actually, you can get the same picture, if you will, if you go right into, I'm just going to make my PowerPoint presentation a little larger so you can see the actual image. So again, if you call the reset method actually happens in the editor. Okay? The main ones we want to worry about and that you will use is the awake and the start method. Okay? So every scene, if I start off a script in Unity, it has built in the start method and the update method. Those are the two things that always start. Hint, hint, there's a question for you on your next test, right? What are the 2 methods that are always included in any new script you create for Unity? Something like that, right? And how do I create a script in Unity anywhere? Well, if I go here, if I want to create a script, right, I could do it in a couple of ways. right? One way I could do it is I could create it within an object. So let's say, for example, I have my capsule, right? Here's my capsule. And I want to create a script that I want to attach to the capsule, right? I can do it like this. I can say add component. Let's do it together. So I'm just going to do this, add component. And inside my component, I want to go down to new script, all the way down to new script. Follow me here, guys. You won't remember how to do this, and then you'll have to watch the video, and you have to hear me talk again for about another hour, right? And then under new script, you notice that there's, this is Unity 5, under new script, you notice that the script has a new behavior script. Let's rename that thing to, as an example, we'll just call this our capsule script. Why not? Capsule script. It's like cube script. So I've made it, but where is it? Where's the script? Well, the default script appears inside the root of the assets folder. Do I want it there? Do I want my defaults, all my scripts to be in the root? No, I want it to be in my scripts folder. So I'm going to drag it out of my assets folder into my scripts folder. And when it's highlighted like this, right, then it's going to go there. Okay, so I'm dragging it in there. So now my scripts folder has my capsule script in it, and two things happened. And it's attached to my object. Okay, here's my capsule script right here. Take a look. Right, so capsule script, it's inside my object. If let's try that again. I'm going to erase it. I'm going to get rid of it. So I'm going to just delete this object. I'm going to go here and delete it. Okay, and delete the script. When I delete the script, it's gone, and it also gets removed from my object. No more object. Notice how the script component, though, is still there, right? Script component is missing the script because I deleted my script. You can always put it back by pointing to it again. The other thing I can do is I can get rid of this component, right? So I can go here and click on the little gear icon on the right and click on remove component. The two are mutually exclusive. You can remove the component and the script is still going to be alive. I can delete the script and the component is still going to be alive, right? If you want to delete both the script and the component, you have to do them separately. Okay, so let's add the script in, but let's do it the other way around. I'm going to add it by right-clicking here in my folder. The second way to do it. So right-click, I'm going to make a new script, new C# script right here like this. Okay, and now it's going to notice it goes right into my component, into my folder, and I'm going to call this thing capsule script again. So capsule script. You can call it whatever you like. We're going to make it so that it makes sense. Notice how when I go back to my capsule, though, it's not attached, and I can attach it by dragging and dropping onto my add component area like this, just like we did last time with the material. Notice that if I go over here, it also works. So in my scene or in my add component, I could attach my script this way if I just drag and drop. Now my script is attached. My script is really empty. And in order for me to see what my script is, if you're using Windows, and when you load Windows Unity 5, it will try and load in Visual Studio 2015 Community Edition, right? You can disable that, by the way. But by default, Unity has a built-in script editor, if you will, called MonoDevelop. So if I double-click on this thing, the script, your default editor will come up on my machine because I don't have Visual Studio on my machine. It's MonoDevelop, and I'm going to be doing a lot of the stuff here in MonoDevelop. But Visual Studio 2013 or 2015, or even Visual Studio Code, for those people who are taking the other courses with me, will work just fine, right? It's just an editor. The good thing about Visual Studio or MonoDevelop is that it gives you really cool syntax highlighting and code hinting. All right, so notice how I have my capsule script. It's called capsule script, and it inherits from, and all scripts do, by the way, for the most part, except for some editor scripts. If you make a custom editor script, this is the one that won't work. But for most part, most of our object scripts inherit from a class called MonoBehavior. That's the superclass of all scripts. Okay? Now notice how we have two functions here, or two methods. One of them is this start method right here, and the other one is the update method. Those are the two methods that we always have whenever we run a script. Hint, hint again. That's your question, yes? If you want to disable it, you can do that, right? And there is a, if I go back to Unity, right? If you want to open the default editor, if I go to Preferences, now everything might be different on Windows machines, but if I go to Preferences here, right? Notice how I have something called External Tools. So I go to External Tools here, right? And notice how my external script editor is mono-develop, right, which is built in. You can choose whatever you want, right? Like for example, if I want to choose Visual Studio Code or Visual Studio, I can choose that. So in here, what you want to do is in External Tools under Preferences, and it might be window preferences for you guys, depending on how it is for Windows, right? What you want to do here is choose mono-develop, the built-in one, which is bundled with your Unity. Try that out, all right? So you can choose whatever thing you want there. Okay, so going back. So if I go back to mono-develop here, this is my default editor as an example. Notice how the ending of this, right, is the extension of this script is the CS extension for C#, right? So that's why Visual Studio is such a good editor for it, because Visual Studio and C#, they're made for each other, right? And I don't have Visual Studio. I only have mono-develop here because I'm on a Mac. But it works very good, very well for what we want to do. Okay, so the start method will fire. This is one of the ones inside of our initialization phase, right? There's different phases whenever you run a project, right? When I run the game, as an example, the game goes through different phases when it starts off, right? This is when all of these things trigger, okay? So let's go back to the PowerPoint. So notice how in the initialization phase, the start method is triggered, right? That's when it's fired. So if I want something to happen right away when I start off my game, typically I want to put the information in my start, okay? Or in something called a wake, which happens before start. And we'll talk about why we do that later on in the course, right? And then you're going to go into something called fixed update. Notice how there's no fixed update in this script. There's no fixed update. There's just update. So what do I do? Well, if I want fixed update, how do I get it? I have to type it, right? And if I want to type fixed update, it would be like this. Void, let's do it together, fixed. And if I press Control Space, right, I try and find fixed update, it won't give it to you, right? Unless you're in Visual Studio, in which case you will get it. If I go wait for fixed update, that's not what I want. I want fixed update. Here's something to note if I want fixed update. Fixed update, right? The fixed update method is for physics. So if I do any kind of physics update, for example, I'm doing some kind of forces, one force hitting another force, that kind of stuff, if I move things with forces and all that stuff, I want to use fixed update. I don't want to use update because update is a different kind of thing. Think about this fixed update as a loop. It runs every frame, right? Every time that, and if I run my game at 60 frames per second, and typically I'm running it at 60 frames per second, 60 times every second my fixed update will run. That's why it's called fixed update. We want our physics to be fixed so that way the simulation runs very smoothly and it's realistic, right? Update doesn't run exactly every frame. It'll give best effort to run every frame, which means if you rely on update to give you a timer or something like that, it may not be exactly every second. It'll run according to the hardware of the machine you're on and the conditions that you're running on. This can be good and bad because most of the times we want to run the game according to our machine, but not so with physics. Physics, we want to use fixed update. So whenever I say that, we have update, fixed update. Why we use fixed update? Physics, right? Fixed update, physics, right? That's how you're mnemonic. But I would never want to use, typically I don't want to use update for physics. Okay, so let's go back to this. There's other ones here too, on trigger. Notice how there's on trigger XXX here. These events happen when the collision starts happening with physics, right? So my on trigger events, on trigger enter, on trigger leave, on trigger stay, all those kinds of events, and on collision enter, on collision wait, on collision stay, on collision leave, all those kind of different kinds of events that I'm talking about right now, they all happen after my fixed update. Keep that in mind. Okay, let's go to the next slide here. And I'm telling you all this stuff. I mean, there's a reason why. I'm telling you all this, and it's important for you to understand because, unfortunately, for some of us, what ends up happening is, we don't quite get the order of execution of events. We don't understand. And we need to when we're running, even if we're running things with Android or iOS. Android and iOS devices have an order of execution of events. When your application, when your app turns on, right? So then, because Unity can export to iOS and Android, it's also going to have a certain order of execution of events because it's going to match kind of what's happening on a device, even a console application. If I run if I'm playing a game on an Xbox One or a PS4, as an example, when the game is loading, certain things are happening, right? It's going through its own order of execution of events. Okay. Input events happen next. So on mouse enter, on mouse leave, on mouse whatever it is. Those are the input events for mouse, right, in keyboard. Then some game logic. Here's update. Happens after the events, right? So update happens way after. So it has first your physics update, then your update. Okay? And then finally, within game logic, we have something called last update. So fixed update, update, last update. You have a bunch of different updates, and they happen in their own loops, their own game loops, right? And they can be used for different things. Sorry, late update. Yeah. The other thing that happens is this. You also have a coroutine that runs in between. A coroutine is almost like a separate process that you can schedule to run side by side with your regular updates in a separate process, and it's in the same phase, right? So you have your game logic, and you can kick off a coroutine that runs alongside your update, right? And it's important sometimes to do that, especially for things like particle effects or other things like, for example, explosions. You want this coroutine to kick off and have nothing to do with this other thing you're doing. It'll do the explosion, it'll finish, and then it'll come back to the main process, right? And we're talking about concurrency here. And then there's some other scene rendering stuff that's going to happen. It's going to render the scene. Rendering means it's going to start drawing the scene out according to what the camera is seeing. Okay? So that's kind of one of the things that it's going to do. Any questions so far? I mention this because, again, it's not just interesting to know, it's kind of critical when you're programming your game because otherwise you won't know how things are working. Here's Ondraw Gizmos. What's the gizmo? Well, in Blender, the gizmo is the manipulator arm. That's what the gizmo is. So if this gizmo right here, as an example, and anything else that's inside our scene view, these are considered gizmos. And by the way, you can turn them on or off, right? You don't have to show the gizmos. Notice in the middle on Unity 5, right? In the middle over here, you can see that in gizmos, right? You can show or hide the gizmos. So there's the 3D icons, your show grid, and so on. You can turn these things off. If I click off the gizmos, right? I don't have to show what they look like, and I can click off show grid. I can click off all the rest of the stuff here, lens flare, and so on. All this stuff you can decide which gizmos to show and which gizmos to hide. An example of this would be the camera gizmo, right? Or the audio source gizmo as an example. You can turn these things off, right? By hiding these things. Take a look. I can just click onto them, right? And the same thing goes with my my manipulator arm here. This is important to understand so you can turn all these things off and on, right? Because sometimes they get in the way. That's why you turn them off and on, right? You're programming a scene and you've got these objects here that are showing, and you don't want to see your camera. It's still in the scene. You just don't want to see it. You don't want to render the gizmo, right? Okay, gizmos. So that's part of it. The other thing is, after your gizmos, your UI events are called. So anything you do with a menu, if you create a button, if you create a text object, anything like that, that renders next, right? And then finally, on destroy. So when I want to destroy objects, when I come down here after end of frame, on destroy. This happens, by the way, this loop that I'm talking about happens every single frame. So 60 times per second, all this stuff happens, right? So a lot of these things get updated and then get rendered and all that kind of stuff over and over again. Okay, so really important stuff to understand. And if you don't understand this stuff, then it can kind of come back to bite you. And things I want to talk about, I want to talk about reset. I've put it up there as a reference card. And what's the awake function for? Again, it's always called before any start functions, especially it's just after a prefab is instantiated. We'll talk about that later on. We'll come back to this PowerPoint. later on for that piece. Let's go back to the next piece. I'm not going to talk. Start is really important. Our start function is when we do a lot of our work. So let's say, as an example, if I go back to my scripting here, and I want to say something like this. Whenever I kick off my game, I want to send a little message to my log, my console, right? And you want to get some console commands because I do a lot of debugging with console, right? So let's go back in here and let's type a new command, right, for Unity. And we're gonna type debug, right, dot, and notice how there's some options. If I press L, I get log, debug.log. And that's the way we do our message. We can send a message saying that we're in the start function. So in the start method. There it is. And let's do a debug.log for fixed update so we can see when it fires. So debug.log, right, fixed update. You're going to see that going to fire a lot of times. You know, debug.log update, right? And if I was to save this, right, I made a change to my script, I save it, and I go back to Unity and I run it. I want to run my Unity now. It happens. Notice how I don't see my log. Where is my log? How do I see my log? Well, if I go to Window, right, notice how I have a bunch of different options. I have services, I have scene, I have game, inspector, hierarchy, project animation, profiler, and so on, all the way down to console, which is the bottom one, right? If I click on console, I can attach my console as part of my scene, and notice how it's moving between fixed update and update. Now, the question I have for you is it equal? Is fixed update and update firing the same number of times, right? If I was to stop this whole thing, right, and if I look at the console, take a look. Update, fixed update, update, fixed update, update, fixed update. It keeps doing it. Then I go update, update, fixed update, update, fixed update, update, fixed update. Sometimes you get a couple of updates. Remember, update is not regular. It happens according to my system resources and stuff like that. Fixed update happens exactly every frame, no matter what happens. It'll force, it's almost like a forced update, if you will. It forces it to happen every frame, for this thing is running. That's why we want to use fixed update for physics. So what have we learned? We know that we can output to a console, and I just open up the console window with debug.log. And debug.log can do this kind of stuff. It allows us to do these things, right? Other things that can really happen for us is if I want to set up a variable, right? I want to set up a variable, like for example, speed. I want to set up an object speed. But I want it to be viewable on my inspector, right? So, because remember, in Unity, you have my scene and you have your inspector. Notice that I have a script here, right? But I don't have a speed value available on my inspector. How do I add it in so that it's available on my inspector? Well, in my script, I can add it in my start menu, or I can add it in as a class object. Remember, this is just like a class in C#. So if you know C#, you know what I'm going to do, right? I'm going to add some comments and call this, these are our private instance variables. So we have some of those, right? And I might have something like a private you know, something like a private Boolean that kind of like is something like is colliding. We'll call it is colliding. So some kind of private Boolean variable that is colliding. And I got to talk about what type it is. I can't just say is colliding, right? How do I declare a variable instance in C#? Do I put it before or after the variable name? So if I want this to be Boolean, then I got to say it's bool, right? Private bool is colliding, and I can set up a default value for it, false. Now this value, because it's private, right? Because this instance variable is private, will not appear on the inspector. It's only available for in my script here like this, right? But if I make it private, so let's make some private variables here, right? Or sorry, public. So here's my public, I don't know, public instance variable. And now let's make it public. And public will make it, it's some kind of number. So could it be a float? Public float number that's speed. We'll call it speed. right? And we'll set the value, the default value, you know, to 0.5, a floating point number, okay? Now when I save my script and I go back to Unity, right? And remember that capsule is, if I click away and click back, right? What I'm hoping to see is that Unity will display this on the inspector, right? Because again, here's my scene, right? Here's my scene, right? And here's my script. And my public float speed property, which I've just declared on my script capsule script.cs. If I go back to here, I'm hoping to see it there. But how come it's not there, right? I did public, right? Here's my private. How come it's not like that? Anyone have an idea why? How about on 4.6? Anyone using Unity 4 in the class? If I make a public floating point variable here inside my class, do you see it on the inspector?
I can see.
Who? In 4.6 or in 5?
I don't know.
Yeah, you can see, but I can't. How come I can't? Right? Notice how I can't see it right now on the inspector. Right? It's here, but when it comes to look, sometimes what happens is different versions of Unity do funny things to Unity, right? Just FYI, right? So notice how if I click away and click back, typically you'd see the, this thing on the inspector. You can certainly serialize it. That's one way of looking at it. And inside code, if I want to serialize an object, I can put square brackets, and if I type serializable, like serialized field, right? I can type serialized field. Serialized field, what it does is it makes it available typically in the inspector if I save. So if I go back now to Unity, right, and if I click away and click back, typically that'll be back. Now, I'm not showing it right now in the inspector for whatever reason, getting a bit of an error, right? But that's typically what it goes. If you create a script in Unity and you serialize it, you get this going. Notice if I run it, it says a compiler errors have to be fixed before you can enter play mode. What's the compiler error? Right? I've got a bit of a compiler error here. Public, right? Keyword float, right? Here's my float, and then here's my speed, right? And I've assigned it 0.5, right? How come this is no good? Why am I getting an error like this? Right? So I do this because this is C#, right? And I'll see if I need serialized field after this, right? And if I go back to my scene and oh, look, there it is again. So when there's an error, right, like I said, it won't show up even if you do the right things, right? Now, if I take serialized field away, I put it there just to force it, but it didn't do it anyway. I was curious, right? And if I go back to the to Unity, right, notice it's still there. And I can modify it here on the fly. So even though the default value is 0.5, I can make it, you know, change. I can change this value, whatever. Now, the speed doesn't make any difference right now because we haven't applied our speed, you know, when it rolls, right? But I can make it apply. Okay, so again, anything you want to serialize on the inspector, inside here, you make it a public property. Notice that this private property is not serialized, but it's part of our script. Okay, let's go back. So that's what's in start. So start, we do a lot of serialization, and update, if I want to update my value, and let's try that out. So if I go back to my script, and let's get rid of some of these debug.logs, okay? So I want to get rid of this debug.log, this fixed update, and I want to get rid of this debug.log in start, right? And what I want to do is I want to declare my stuff here, right? But I want to initialize here, right? I don't want to, typically this is bad form, okay? If I initialize before my start method or before my constructor, this would be bad, considered bad, right? So let's not do this here. Let's just do one of these. And in my start method, we'll do it. We'll say, how do I access my speed property, by the way? How do I do it? It's this keyword, this.speed, right? Because it's a method that or a property that belongs to my class. This.speed is equal to 0.5, right? I can assign it, and it has to be 0.5f. Okay, cool. So that's one thing. The next thing is this. If I want an update, I want it to increment, I could do something like this. This.speed, right, plus. I could do that, this.speed plus, which increments the value of speed. And if I want to print it out, I can do it the same way as I do in a console command, right? I could say, instead of update, I can change this to speed, and then, right? Plus, I can concatenate this dot speed, right? So let's see what we do now when we run this thing in the editor, right? So if I go back to Unity, then I press play, and if everything goes well, if I look at the speed value, if I go to my console, notice that the speed value is constantly increasing every frame, and it's increasing quite fast, like it's already at 400, right? And the reason why is because there's no upper limit to the speed, right? It's going to keep increasing to infinity. It's almost like an infinite loop, right? Actually, let me take that back. It is an infinite loop until you stop the game, right? Once I stop the game, the loop stops. Okay, so let's go back. So again, I've got my speed. I did my speed plus plus, which is an incremental value. I'm putting out the speed. Let's do this. Let's make a little if statement. If my speed, this dot speed, is greater than 10, right? If it goes higher than 10, what do I want it to do? I want to reset it to 0.5. So I want to say then this dot speed, right, is equal to 0.5. So it's going to loop between, 10, a maximum 10, let's say greater than or equal to, greater than or equal to 10, and then it'll reset the speed to 0.5. This is just a test to show you that what happens. And again, I can't do 0.5. It's got a 0.5 f, right? Well, if that's the case, that I'm doing this over and over again, if it was more than one line I was executing, it almost beggars that I should probably make it into a method, right? If I'm executing the same group of lines over and over again. Okay. Let's check this out. I go back to Unity. I've saved my script. I go back to Unity and I refresh. I start playing again. When I play again, notice that it goes up, but this time it goes up to 10 and then it resets to 0.5. So it's like a loop, right? Keeps looping over and over again. It keeps resetting. So anything that works in C# that you know about, ladies and gentlemen, you should be able to do here in Unity. If you know C#, you know a lot about Unity scripting already, right? There's some nuances because we're using a script. Notice that this class here, there is no program class. There's no starting class. What's the starting class in Unity? Well, there is none, right? As soon as you attach a script to a component, in the start method, if you've put something in the start method and put something in the update method, if you override those methods, right, they will trigger right away. It'll start right away for every single component. So you can have 20 components, each one having its own script, and they're going to all run separately, all at the same time within the same update function. There's not one single class that's going to control everything else, unless you choose to make one. Okay? So that's a little different than what we're used to in C#. C# you have one class and it kind of controls the other class, almost like a starting class or a driver class, just like you do in Java, right? But then once it's running, it controls the other stuff that's going on, right? Not so in Unity. In Unity, it happens in the background. That's your mono behavior class that's running already, okay? Questions around this stuff? We're going to finish off this PowerPoint next day, that means tomorrow, and I'm going to give you your assignment tomorrow, the details of your assignment, because we've run out of time today. It'll be due 2 weeks from now on the Friday. So it'll be due 2 weeks from now on the Friday, means that's February 5th, I believe, on Friday night at midnight. It's going to be open until Monday, right? The few days later, the 8th, worst case, and then it'll shut. That means you have, worst case, if you're going to be late, Saturday, Sunday, Monday, and then it's done. Because by then you're going to lose 20% for the first day, 10% every day after that, right? Until you're done, right? So what I encourage you to do, even if before tomorrow, is because one of the requirements is to do a tutorial, right? To kind of figure it out. We're going to be starting off with this space shooter tutorial that's right online, right on Unity, the Unity website. So please go ahead and do this space shooter tutorial. I kind of talked to you about this last week, and I'm sure no one's done it. Who's actually started? I know some people started in the back. Anyone else start this space shooter tutorial? Again, please, when I give you this tutorial to do, please don't skip it. You need to understand how we do 2D, and this is one guy's way of doing it. I'm going to show you another way starting tomorrow, right? We're going to start doing our 2D tutorial tomorrow, right? But take a look at this thing. It talks about setting up the project, and each step has a video attached to it. Now you can certainly, and this gentleman is a good guy, you can certainly listen to everything here, right, as an example, but you want to kind of speed up. This version is for Unity 4, right? That's what this thing was made. Notice how they have get the upgrade guide for Unity 5 here, right? And they have the upgrade guide for Space Shooter right here. Please follow the manual. There are some steps you need to take for each of these steps to make sure that it runs with Unity 5. If you're using Unity 4, the machine's in front of you, the computer's in front of you, you're fine, right? And I also have up online a finalized version of it that works in Unity 5 for me, right? So if I go to github.com, and if I was going to go look at Centennial College, because this is where we're going to be sharing everything, if I look under COMP305, right? So if I look way, way down here in the bottom, there's going to be the Space Shooter tutorial, right? Or Space Shooter example that's way, way down here, right? Like way inside my stuff. Here it is. Here's Space Shooter. I developed this last semester. So this is a working version of Space Shooter if you want to take a look at it. So this is how I developed it. Now it's slightly different. There's some minor changes here that I had to make it run in Unity 5. And I'm sure I have to make more changes now with Unity 5.3, right? So if you can't make yours work, at least take a look at this to see what I did to make it work. And you can always download the project and run it. Okay? Now it's required because when we do our game assignment, which I'm going to give you tomorrow, it's going to look like this, right? Notice how it's worth 10% of your final grade and all that kind of stuff. And you need to do this tutorial. It tells you, based on this tutorial, you're going to develop your own game. I don't want the tutorial back. I don't want you to give me the tutorial as your final game. That would be bad. I would give you 0 for that, right? Give me your own game, right? Based on the stuff you learned from the tutorial. Make your own 2D game. And we're going to talk more in detail about this tomorrow. Okay? Questions before we end off for the day? All right. Ladies and gentlemen, we'll see you tomorrow. Thank you.